probability can simply be defined as the measure of chances or the likelihood of something happening. So in short, these two simple definitions can be given for probability. Sample spaces. Sample spaces are all the possible outcomes when experiment is performed. Let us look at simple experiments. Okay. Good. So we are looking at a coin. Coin is tossed twice. So the question says a coin is tossed twice. List all the possible outcomes. Now, what are the outcomes of a coin? Basically, a toss of a coin. Let me use blue ink here. Good, so that it will be more visible. Now, a toss of a coin. Of a coin is always given as 2 to the power n, where n equals to the number of tosses, the number of throw. Okay, good. So where n equals the number of throw. So if you say a coin is tossed twice, it means that the sample space is S. S here will be equals to where S equals to 2. Let me come to yes, 2 to the power 2, giving you 4. So the total sample space when a coin is tossed twice is 4. Now let us look at the spaces. If we are to list all the elements in S, then we are definitely going to get our S to be equals to, a coin has two sides. It has the head and the tail. So opening our braces, we have the first part. If the first throw landed on head, the second throw too can land on head. This is the first outcome. It can also be that the first throw can land on head, the second throw can land on tail. This is another outcome. The first throw can also land on tail, the second throw can land on head. Another possible outcome. And last not the least, the first throw can land on tail and the second throw can land on tail. So we see that we've got as many as 4 different outcomes if a coin is to toss twice. Now this indication means that the total number of sample space, S here is equals to 4 because the coin is tossed twice. So a toss of a die is equals to 6 to the power n, 6 to the power n, where n equals the number of throws. The number of throws. Let me put S here. Okay, where n equals the number of throw or throws. Good. So let's see an instance where a die is tossed once. We have to list all the possible outcomes. All the possible outcomes. to list all the possible outcomes. So we are going to have our sample space. So our solution will be like solution. Our sample space S will be equals to, we always put it in braces. So we've got the first row can be 1, second row can be 2, 3, 4, 5, and 6. Mind you, each and every one has a common chance of occurring. None has a chance than the other. The throw of the die, any of these phases can show up. Situation whereby the die is tossed twice. Let's say a die is cast 2 times. A die is cast twice. What are what are the possible outcome? Possible outcomes. Good. Okay, we'd already known that when we toss a die, the formula is given to 6 to the power n, where n equals the number of throw or the tosses. So with such, our solution is going to be S here. The sample space is going to be 6 to the power 2. And 6 to the power 2 here is going to give me 36. So we are supposed to build a chart that contains 36 spaces. So if we are to look at it, we can just draw a simple table and put the chart. But basically, when questions are being asked, it's not always advisable that you have to draw the table to get all the 36 spaces. But you can use the sample spaces in both toss to be able to work it out. Listen, when we have a die being tossed twice, is the same as 2 dice tossed once. When I toss 2 dice once, it's the same as when I toss a single die twice. And the same thing goes for coin. When I toss 2 coins once, it's the same as when I toss 1 coin twice. So the number here that are present will be equivalent to the number of truths. So just bear that one in mind. Good. Probability of an event or probability of events. Simply, when we say probability of an event, we say it is a subset of a sample space, which means that given probability of, let's say, P of, let's say, A is equals to number of elements in A, number of elements in set A over all the outcome over the total outcome over the total outcome. Okay, so the total outcome can serve as the universal set or a set which A belongs to. So the A will always be a subset of the universal set. So when we talk of probability of an event, we simply express it as what? A subset of a subset of a sample space. Let's take an example. So the question reads, a fair die is tossed once. What's the probability of scoring an even number? So we have seen that the fair die is tossed once. So know that the toss of a die is equal to 6 to the power n. Then our S here, which is going to be, let's see, solution to this question. So solution, come here, solution. Good. So we have to get our sample space for S. Then S here, the die is tossed once. So we know we are going to get 6 spaces. The spaces are 1, 2, 3, 4, 5, and 6. I close it. Then with this, we have to list all the even numbers. So let the even numbers be, say, E, set E. So set E is going to be, come down, E here is going to be even numbers. And the even numbers are the subsets. They are subset of the main set. So what are even numbers? Numbers that are easily divisible by 2. So 2 is an even number. So 2 here. Then we've got 4 is also an even number. 4 is an even number. Then we got 6 also being an even number. Then how many numbers do we have? Judging from our formula. So we have P of E coming down. Probability of getting E is now going to be equals to number of E, number of elements in E, elements in E over the total number of elements, which is S. Number of elements in S. So what do we have? The number of elements in E are how many? If you check, there are 3. Let's go back and see. We got 1, 2, and 3. So they are just 3. And the total number of elements in S. In S here, let's get it done. Number of elements in S. Let me bring my bar very clearly. And that one is going to give me what? 6. So from this, I'm going to get what? 1 on 2. So the chance is half. So when a die is tossed once, the probability of scoring an even number is 1 over 2. But let us see compound events. You say a compound event is an event with more than one simple event. Example, a die is cast and 2 coins are tossed once. So it means that the die is cast once and the 2 coins are also tossed once. Good. So list all the possible outcomes. II, what is the probability of scoring a 5 and no tail? Solution. So we see how we solve the solution. Okay, so we say a die is cast. So we can make the dice sample space for the die to be, let's say, D. So SD, or sample space for the die, let it be SD. Let me come down here. Okay, SD like this. So the SD is sample spaces for the die, and the die is tossed, is cast once. So it means I'm going to have 1, 2, 3, 4, 5, and 6. Okay, then coin is also 2 coins are tossed twice, and the 2 coins, because there's 2 coins, the total sample space is going to be 4. So we're going to have that one be, let's make that one SC. So with SC, I have the spaces to be we got, it can be H or head, okay, then we got head tail, head tail, then tail head, then we have tail tail. Good. Now, probability of scoring a 5. So we just write P of a 5 here, P of 5. We can see the number 5 is occurring 1 out of all the 6 spaces. So that one is equals to probability of scoring a 5 here. But, is going to give me 1 out of the 6 spaces. Okay, and P of no head, sorry, no tail. P of no tail means that there shouldn't be tail in the setup, so it's going to be just all HH, that is all head. So this is no tail. So we got no tail here. So we got here P of no tail, P of no tail, no tail. This one also gives me 1 is 1 out of the 4 sample spaces. Good. Now we are being told to find a P of a 5 and no tail. Anytime you encounter the term "and" in mathematics, it means multiplication. So the II section coming down here, II here, P of 5 and no tail, the end, as I said earlier, equals to multiplication. It's going to give me 1 on 6 times 1 on 4. Let me read this. Times 1 on 4. let me say 1 on 4. This figure giving me head. One over 4. So when we multiply 1 on 6 by 1 on 4, we are going to get 1 on 24. So the probability that we will score a 5 and no tail is very, very slim.